Compression ratio and why is it important? Compression ratio is a ratio of the volumes when the cylinder, you've got a cylinder here inside your engine. The piston is down at the bottom, and this is the lowest point the piston is ever going to go down, rotating the crankshaft. Now, then the next step is to compress the air in here, and the piston's going to move up, as you can see here. Step 1, step 2. Now, as this moves up, it compresses the air in here, and now you've got a different volume. The compression ratio is a ratio of the volume in step 1 over the volume in step 2. Say there's 8 times as much space in here as there is in here, then you'd have a compression ratio of 8 to 1. Now, why is the compression ratio important? Well, it plays a big role in efficiencies, and it also plays a big role in diesel engines and why we need to use premium fuel. So, efficiencies. The greater the compression ratio, the greater the thermal efficiency, and therefore the better gas mileage you're going to get. If you've got a car with a greater compression ratio, for its specific engine, it's getting better fuel economy than it would if it had a lesser compression ratio. Now, diesel engines have a major advantage over gasoline engines in that they can have much higher compression ratios. If you want to understand this further, I've got another video, but basically the fuel is injected after the air is compressed in a diesel engine, and so it's allowed to have much greater compression ratios and therefore greater fuel economy. Finally, compression ratios play a big deal with what fuel you need to pick. Say your car has a 10 to 1 compression ratio, well then you're probably going to be recommended to have premium fuel, and the reason for this is so that you don't have engine knocking. When your piston is compressing and the gas vapor mixture, the fuel and air that you've got mixed in there, reaches a certain temperature, it's going to combust. You can only have a high enough compression before that will happen. So in gasoline engines, there's a limit, and then you'll have a spark that'll ignite to explode the gases. Well, in diesel engines, it just compresses the air and then it explodes. So in gasoline engines, which want to have higher compression ratios, use a higher octane fuel or premium fuel, and what happens is these fuels, higher octane fuels, combust at a higher temperature.